Okay, Assalamualaikum class. So previously you have watched two examples on the mesh analysis, right? So now we move to the case number 3. That is what we call additional names here, what we call super mesh. So what is actually super mesh? It's still mesh analysis where you are going to use KVL, but we will identify how this super mesh circuits looks like. Okay, so super mesh is actually a mesh analysis with the current source. So in the previous example, if I go back to the previous example, where you can see only the voltage source that appear on the circuits, right? And same here, only voltage source. But for the super mesh, you are going to see what is called a current source. Okay, a current source. So now let's look at the circuits. So this is the circuits that you see from the previous example. You only can see what is the voltage source left and right. So there is no current source. This is not super mesh. Okay. So what is actually super mesh? What will happen when we start to add the current source? How do you know this is a current source? There is an arrow and it's saying here like 5 milliampere or some variable. Okay, so when there's an arrow, so that is a current source. So where the current source located is matters. So for example, in this case, the current source is located only at one mesh. And this one, the current source is located between two loop or between two mesh. So which one is actually super mesh? So let's see on the left circuit here, when the current source is only connected at only one mesh, either the most right or the most left, we call this one case 2. So this is not super mesh. Okay, so what is actually super mesh is actually the current source that exists at two or more mesh. So here we have one mesh and here we have another mesh. Then suddenly between these two mesh, there is a current source exists in between these two mesh. So we call this one super mesh. Okay, so what is actually super mesh? It results when two meshes, so how many mesh we have here? 1 and 2, have dependent or independent. So what does this mean? Dependent means the circle. So let's say this is 3 ampere. We call this one dependent. But we call this one independent. It didn't depend on anything. But if it is a diamond shape, and now it depends on I naught, for example. So this is what we call dependent current source. Doesn't matter whether it is dependent or independent, as long it exists between two or more mesh 1 and mesh 2, it exists in between, we call this one super mesh. Okay, so how are you going to solve this one? You're going to exclude the current source. So what does that mean by exclude here? Wait 1 minute. Okay, so I'm going to exclude this current source and you're going to do the loop from mesh 1 continuously to mesh 2. This only happens when you have super mesh. What is super mesh? The current source that exists in between two or more meshes. So this is a super mesh, right? How are you going to solve this one? Exclude it by having the KVL across these two loops together. Okay? So let's see the circuit again. So now you have a voltage source and then you have a current source. So now this current source exists between two mesh 1 and mesh 2. And there is a resistor in parallel. So what you need to do now, you're going to exclude anything that is series with this super mesh. You're going to exclude this one. And this one maintain I1 and I2. But then you're going to make a loop across this super mesh towards the mesh 2 until you finish the complete loop. Okay, so this loop means that the one that you are going to have equation on the KVL. Okay, how about these circuits? Okay, in these circuits you have how many loops? 1, 2, 3 and 4. So in between, which one is super mesh? So this one is between I1 and I2, right? So we can call this one super mesh. And this is dependent current source. It is between I2 and I3. We can call this super mesh. So what you need to do, you're going to exclude this one. And then having your KVL equation across this bigger loop until here. So we'll see one by one how to get the equation from this super mesh. Okay. So the first important concept, you need to be able to identify what is actually super mesh. Supermesh is the current source, either dependent or independent, and it exists between two or more mesh. It exists in between two or more mesh. So what is the properties? The current source is actually not completely ignored. It provides the constraint to solve the mesh current. So a super mesh has no current of its own, so it requires both actually, KCL and KVL. So at first you're going to ignore that one, right, and make the KVL, but at the last step you need to include that one and use the KCL. So I will show you after this. Okay, now let's see how you're going to do the steps. Okay, so now you already identify the circuit is having super mesh. Okay, and then exclude the source, apply KVL by excluding the source, and this is important step. The last one, you need to apply KCL at this super mesh. Because you know super mesh is a current source, right? So you're going to apply KCL at any nodes near to the super mesh. Okay, so let's see one example. Okay, now first, here are the steps. First one, identify the super mesh. Is there any super mesh? So now look at the current source. Oh, okay, there is a current source here. And this current source exists between two mesh, mesh 1 and mesh 2. So can you call this one super mesh? Yes, so means super mesh is actually at 3 ampere. So step number 2, exclude. So means you're going to exclude this one. What about 1 ohm? Anything in series with the current source, you are going to also exclude it. Okay, so once you already exclude it, you're going to do KVL. So where is the KVL? Starting from here, go down. You are going to exclude this 3 ampere and 1 ohm, right? And then go here until here. This will be loop 1. How about here? Is like normal will be loop 2. Okay? Okay, now let's try to write the equation for loop 1. Remember the keyword just now? Step by step, slowly. Once you got the concept, then you can do it fast. Okay, now start from here. Let's have a loop at the super mesh. Start from here is minus 6 plus. Now plus the current across this 2 ohm is actually I1, right? So become 2. But this 2 is crossing between I1 and I3. So you need to find the net current. So what is the net current? I1 minus I3. Got it? Because it is in between, right? And then go down. Oh, there is a super mesh. You're going to ignore it. And the next you go to the 4. So become 4. What is the net current? So now 4, what is the current at 4? It's not I1. The current at 4 is I2. So become I2. But it's not only I2 because you have a current the other flowing at the other side, right? So I2 minus I3. Okay? Plus, you're not finished yet. And then you get 8. 8. What is the current across 8? That is I2 equal to 0. Okay, so let's try to simplify this one. So it becomes minus 6 plus 2 I1 minus 2 I3 plus 4 I2 minus 4 I3 plus 8 I2 is equal to 0. Then you simplify further, make the sequence correctly. I1, I2 and I3 minus 6 I3 equal to 6. So you got here equation number 1. So that is the KVL at the Supermesh. So I may add here at Supermesh. So is there any other KVL needed? Yes, you have another KVL here. Loop number 2. So just make another equation. 2I3 minus I1. Why? Because this is the current flowing here is I3. The current flowing down is I1. Plus 2I3, it is here. Plus 4. 4 is the current flowing between I3 and I2, right? Because you are in the loop number 3 here. So become I3 minus I2 equal to 0. So just take out it together. You become plus 2I3 plus 4I3 minus 4I2 is equal to 0. You sequence is by I1, I2 and I3. Then it be 4I2 plus 4I3 is equal to 0. Okay. So now you have 3 unknown but only 2 equation. So what is the last equation that you need to do? Is this one, step number 4, KCL at the Supermesh. Okay, so how you are going to do that? Okay, step number 3, KCL at Supermesh. Okay, now look at this Supermesh. You have a node here. KCL means you need to have the node, right? So the current flowing down is 3 ampere. So, and then here is your 4, and then here is your 2. What is the current flowing to I2 is, or you can use the node here. Sorry, this is a bit complicated because you have 2 different direction of the current, right? Okay, now let me redraw it. You just ignore this one. Okay, how about this one? What is the current flowing here? Let's say this is node B. Okay, now go to the node B. So what is the current flowing node B is I2. Correct? What is the current flowing out node B is this one. If we go down, this one is I1. So what is the current flowing into the node B? There is 3 ampere. So by having the KCL, so what is the current entering B is 3 plus, entering is 3 plus I2 is equal to I1. So make it a sequence, I1 plus minus I1 plus I2 is equal to minus 3. So then from these three equation, you use your calculator and then you can get your I1 is equal to 3.474 ampere, I2 is 0.474 ampere, I3 is equal to 1.1052 ampere. Same with the answer. So tips, another tips here. So when you want to do your KCL at the Supermesh, okay, find the current that is not having 2 different directions here. So you may use here, but this seems complicated, right? So go to the other end. So you know here is I2. The current flowing here is I1. The current flowing down is 3 ampere. Then you can get this last equation at the Supermesh. Okay. So this is how you solve for the Supermesh. Okay, so for example 7 and 8, we will go through in the class together. Okay, and as the summary, how you solve for the mesh analysis, loop, KVL, imaginary current. How you look at the Supermesh. If there is a current exists between 2 mesh, you need to exclude it and use the KVL in between. And how is the step? Identify first the Supermesh. Exclude the current source or any elements that is connected in series. Apply KVL by excluding the Supermesh. And the last equation is apply KCL at the Supermesh. Okay. So that's all for the Supermesh. We go through more example in the class. Assalamualaikum warahmatullahi wabarakatuh.